Okay, so next up we're going to move on to talking about how we classify equilibria. And if this thing that I drew on the direction field was a little bit like too fast or confusing, don't worry, because we're going to do that a lot more slowly in the example of how we classify equilibria. You'll kind of see how these arrows come together in a slower example. But real quick, I want to write down the steps so that you know how to do this section. And so what we're talking about is how we classify equilibrium values. And so from this example that I did above, we kind of get the idea that somehow we can talk about the behavior of solutions and how they relate to like going to this equilibrium K based on the directions that those arrows go, or the sign of F, which determines the direction of the slope around the equilibrium. And so we're going to formalize that into some steps we follow. So we classify the equilibrium values y star, or in this case n star, by examining the sign of f of y. So examining the sign is the same argument I was making for slope being up or down. And we're going to think about that above and below the equilibrium value. That's our y star. So in this example that I kind of showed you briefly, for me to know when does the solution become K, I had to think about what happens if you start below K, what happens if you start above K, and in both those cases, my solution's headed in that direction. So that's why I have to think about examining the sign above and below the equilibrium. And then when we do that, it's going to tell us if solutions are drawn towards or away from that equilibrium value y star. And the way we're going to visualize this is going to be another tool, and we're going to call that a phase portrait. And so you may remember when we were using that D-Fields software, it even called things phases. So this thing we use to study equilibria has a name that's definitely related to direction fields somehow. And I'm going to leave all this white space here and actually go to the next page, because I want you all to see in one place when I'm writing it the steps I'm about to tell you. I don't want to move pages on you. But that space isn't for anything, so in your notes, go ahead and just keep going the way you are. So to build a phase portrait, we're just going to follow a few simple steps. First, we're going to need to calculate our y star so that f of y star equals 0. So we need to find those equilibrium values. And then what we're going to do is we're going to put all those y star in order on a number line. And then we'll go ahead and examine the sign of f of y star between all those y star. And then, so these steps 1 through 3 are things that we did in our previous example. So we solved that dn dt equals 0 to find 0 and k. And when I was drawing my direction field, I naturally had a number line, the n-axis, and 0 was below k. And then I thought about what are the slopes above and below all those values. So that's sort of what steps 1, 2, and 3 are. And then step 4 is where we're going to be a little bit different from the direction field. So we're going to be drawing arrows on the number line that we've built. So that would be sort of this n-axis on this picture. Draw arrows up, if there's a positive sign in that region, or down if there's a negative sign in that region. So for all the places that you looked at the sign in step 3, you're just going to draw an arrow up if it's positive, down if it's negative. And then you're going to look at those arrows in step 5 to actually classify our equilibria. And there are 3 possible classifications. They're unstable, stable, and semi-stable. So they're going to be unstable if arrows point away from the equilibrium. They're going to be stable if the arrows point toward the equilibrium, and they're going to be semi-stable if arrows point through the equilibrium. And I'm going to move that all over to the side so I have a bit more room on the screen to draw what I mean by away, toward, and through. So just imagine that those are parts of a number line where I've indicated y star somewhere on it. I will switch back to the red, which is the color for arrows now. So away is going to look like this. So I've got arrows pointing up, above, and down below. And then toward is going to be arrows pointing down above and up below. So if you follow the arrows, you would go toward it. And then through is going to mean that the arrows point the same direction on either side. So they're either both up or both down. And the idea is you're just thinking about if you were following those arrows, would you go towards y star? And I'm going to go ahead and pause here, and then in the next video we'll actually do an example where you can see how this works. But those are the overall steps that we'll follow.